Stress and strain. Every component in a linear motion system experiences some form of loading due to applied forces or motion. The component's reaction to these loads are described by its mechanical properties. The mechanical properties of stress and strain play an important role in determining whether the component can resist the application's loading conditions or not. Stress and strain describe the forces causing the deformation of the objects. Deformation is known as the change of the shape of an object by applications of force. Very small forces can also cause deformation. Stress is quantity that describes the magnitude of forces that cause deformation. Stress is generally defined as force per unit area. When forces pull on an object and cause its extension, like the stretching of an elastic band, we call such stress a tensile stress. When forces cause a compression of an object, we call it a compressive stress. An object or medium under stress becomes deformed. The quantity that describes this deformation is called strain. Strain is given as a fractional change in either length or volume. The material's stress-strain curve represents the relationship between stress and strain for materials. The strain values are plotted on the curve corresponding to the strain incurred by different loads on the object. There are several types of stress and mainly categorized into two forms that are normal stress and shear stress. Stress is said to be normal stress when the direction of the deformation force is perpendicular to the cross-sectional area of the body. The length of the wire or the volume of the body changes, stress will be at normal. Normal stress can be further classified into two types based on the dimension of force. They are tensional stress and compressive stress. Tensional stress is the stress that tends to pull something apart. It is the stress component perpendicular to a given surface, such as a fault plane that results from forces applied perpendicular to the surface or from remote forces transmitted through the surrounding rock. Compressive stress is a force that causes a material to deform to occupy a smaller volume. When a material is experiencing a compressive stress, it's said to be under compression. A high amount of compressive stress, such as tensile stress, leads to failure due to tension. Shear stress is the stress component parallel to a given surface, such as a fault plane, that results from forces applied parallel to the surface or from remote forces transmitted through the surrounding rock.